Hello everyone, we are Group 15. We're here to present you with our alarm clock timer. I'm Ziyuan Chu.
I'm Feng Tai.
I'm Minchuka.
So here's our detailed block diagram. We have an overall clock module and there's some blocks inside it to choose between alarm clock and timer clock. And for alarm clock, there's a binary clock inside it as it will assign the time that we want to show to the visual controller and the pixel generator. And then they will send the output RGB to our screen. And for timer, it's the same. The timer module here will send the time that we want to show to the visual controller and the pixel generator, and then they will generate the RBG. And here's our detailed code. So first we want to talk about the binary clock. We have some inputs. The first one is the 100 megahertz clock and it's from FPGA. And we have a reset button and a mode button. Also, we have second button, minute button, and hour button. These buttons are to adjust the time. And the main output is the numbers that we want to show. As we use button as an input, so we need debouncers. Here's a 3D bouncer for the three buttons. And also, we want to get a 1 hertz clock, so we use a clock divider. So it works mainly as we have a counter, and we count to around 50 million, then our 1 hertz clock will flip one time. And here's the main logic of our clock. So for example, here's the second. If we reset, then we set second counter into 0. If we press the button, then we increase it by 2. If it's 59, then we change it to 1. And if we did not press the button, then if it's 59, then we set it to 0, where we just increase it by 1. And it's the same for the hour and minute. And also at the end, we want to split the number. For example, if second counter is 59, then we split into 5 and put it into second first, and 9 into second. And that's the logic for the binary clock.
And now I'll introduce the timer. The logic of the timer is very similar to our binary clock. Which we did is we take away the three buttons, which is used to set the timing for the alarm clock, which is useless in this module, and we add to input start and pause as switches into this module. So what we want is a button, a clock that we can control. So we add a JK flip-flop before our clock signal, as you can see here. So we assign the start as J and pause as K. So whenever J is 1, the Q will be 1. And whenever the mode is on timer mode, there will be a clock 1 signal, which is high, and the clock can start ticking. And whenever the pause is high, then the Q is low, then the clock 1 will be low. And there will be no signal for the clock, for the timer, and the clock will stop ticking. That's basically what we did for the timer. And we noticed that when we are pressing the restart actually reset the reading for the unused mode as well. We want to avoid that case, so we just did a simple logic gate here. So we assigned a wire called reset2 to mode ended with reset in the timer function, because our select line for timer is 1, and we did the same for the binary clock. We assigned a wire called reset1 to the inverse of the mode ended with reset, and that helped us to correctly reset our readings.
And then I will go over visual controller very quickly. So the visual controller mainly just track the position and send horizontal sync and vertical sync to the pixel generator. And so if it's in the pause area, then the horizontal sync will be 1. And same for the vertical sync. And also there's a display true. Only when the position is in the display area, the display true will be true. And then here's the pixel clock generator. So the main logic is like we get the position and then we find this position in the room. For example, it is here. It's a 0. So we go back to pixel clock generator. If it's 0, then we just give it a color as black. Otherwise, we give it as white.
So finally, we also have some code that was not added to our final top module. So we have this countdown binary clock, which functions very similar to our binary clock function, using the same variables and the same logic. However, right here, instead of adding one, we would be subtracting one, like you would see it in your typical timer. But we were having issues implementing this into the VGA, and due to a time constraint, we weren't able to implement this into our overall top module. Furthermore, we decided to experiment by trying to get a real-time clock so that we can get like alarm functionalities and be able to set alarms at specific times. And so in order to do this, we used MATLAB to actually create a real-time clock. And this clock would generate a real-time clock. And these 4 through 6, it stands for the hour, minute, and seconds. And so MATLAB would generate this, and we would have this receiver module, which is a module that communicates to the FPGA using UART. And so it has a clock, a reset, an input, and then an 8-bit output as well. And so this was UART module. And so we would actually use this to instantaneate our real-time clock. However, we were having issues converting the serial data of it to usable data that we can then display on our VGA. And unfortunately, we weren't able to get this working as well. And finally, we have our constraints file, which includes all of our buttons and our switches. It also includes anything we needed for our VGA, as well as the interface for our UART.
Hello guys, this is the FPGA board for our project. So I'm gonna introduce the buttons and the switches to you. So this button here is our button under the alarm clock mode. When you press this button, this will increment the reading of the hour by 1. And similarly, this is the minute button and this is the second button. So this button on the top is a reset button. It works under both the alarm clock mode and the timer mode. When you press this button, it will reset the reading to all zeros. And here is the switch mode. This is a switch for the mode. Under off condition, it indicates that we are currently under alarm clock mode, and when we push the switch upward, which makes it on, it will turn to the timer mode. Since we don't have enough buttons, we are only leaving with one now, we will use the switches for the start and pause function under the timer function. So this switch here is the start, and this here is the pause. When we push the start upward, the timer starts, and we push the pause upward, it stops. So basically that's it. And now we'll show you how our clock works. As you can see, now the reading is 22, 53, and 28 seconds. Now I'll press on the minute button to increment the reading of the minute. As you can see, the number increases, and after it reaches 16, it will go back to 0. And as well as the second button, it will increment by, it's incrementing by 2 because the reading only alters after 1 second, so it makes perfect sense. And now I will increment the hour as well. You can see it's looping itself every 24 hours. And when you press the reset button, it should reset all the readings to 0. There's a short delay, so like a couple of seconds, so it should be reset to 0. Now I'll show you the timer mode. I push up the switch for the mode button, and now you can see there's a small T indicating we are under timer mode. So in this mode, when I push start, it will start count. And whenever I feel I want to stop it, just push pause. And the timer will stop. And if you want to start recording for new stuff, just press restart. And the timer will be set back to 0 again. So that's all for our clock. Thank you.